Picture a celestial marvel so strange and breathtaking, it defies everything we thought we knew about galaxies. Floating in the void of space, a perfect circle of stars glows like a cosmic jewel, its center almost empty, a surreal sight that looks more like a portal to another dimension than a typical spiral or elliptical galaxy. These are ring galaxies, some of the most enigmatic structures in the universe, where the rules of gravity and time seem to dance to an entirely different tune. And what's even wilder, they're hiding secrets that could rewrite our understanding of how galaxies live, collide, and evolve. Now, imagine peeling back the layers of one of these cosmic oddities, only to find not just one mystery lurking inside, but 30 strange, baffling phenomena that range from ghostly star formations to unexplained gravitational quirks, each one more puzzling than the last. Some of these rings shouldn't exist according to our current models. Others pulse with energies we can't yet explain, or harbor black holes behaving in ways that leave even the most seasoned astronomers scratching their heads. This isn't just a tour of pretty space pictures, it's a journey into the deepest, most bewildering corners of the cosmos, where every discovery raises more questions than answers. So why should you care about a bunch of far-off rings in space? Because they're not just distant curiosities, they're cosmic laboratories. Each one holds clues about how galaxies survive catastrophic collisions, how dark matter shapes their fate, and even how our own Milky Way might one day transform. This video isn't just about listing weird space facts. It's about stepping into the shoes of the scientists racing to unravel these puzzles, feeling that same rush of wonder when the universe throws them a curveball. By the time we're done, you won't just see these ring galaxies as beautiful oddities, you'll see them as the front lines of astrophysics, where the next big breakthrough might be hiding in plain sight. Ready to dive in? Let's go. The first mystery we encounter in these cosmic rings is something so eerie. Astronomers call them phantom rings, ghostly halos of stars that appear to hover around the main structure like celestial echoes. These faint, almost translucent rings shouldn't exist under our current models of galaxy formation. Most ring galaxies are thought to arise from violent collisions, where a smaller galaxy punches through the center of a larger one, sending shockwaves of stars rippling outward in a perfect circle. But phantom rings, they're different. They linger far beyond the main ring, sometimes multiple times wider, with no clear trace of the collision that could have created them. What makes these phantom rings truly baffling is how they defy gravity's rules. Stars in these faint structures move slower than they should, as if some unseen force is holding them in place. One leading theory points to dark matter, the invisible scaffold of the universe acting like cosmic glue, subtly shaping these ghostly rings over billions of years. But here's the twist: the distribution of dark matter needed to explain these rings doesn't match what we've observed elsewhere in the cosmos. It's as if these galaxies are playing by a different set of rules, whispering secrets about dark matter we haven't decoded yet. Take the galaxy known as Hoag's Object, one of the most famous ring galaxies, which appears to have not one but two phantom rings encircling it. The outer rings are so faint, they were only discovered with advanced telescopes, and their stars are oddly sparse compared to the dense, bright core. Some researchers suggest these rings might be relics of ancient mergers, long after the initial collision faded, like ripples in a pond that refuse to dissipate. Others propose they could be evidence of rare, slow-motion galactic encounters, where the gravitational dance between galaxies stretches across eons, leaving behind these delicate stellar fingerprints. The deeper we look, the stranger it gets. In some cases, phantom rings seem to contain stars much older than those in the main galaxy, hinting they might be survivors from an even earlier era, somehow preserved in this ghostly embrace. If that's true, these rings aren't just oddities, they're cosmic time capsules, offering a glimpse into the universe's turbulent youth. Every new observation raises more questions. Are we seeing the aftermath of multiple collisions? Is dark matter behaving in ways we've never predicted? Or could there be entirely new physics at work, hidden in these faint, glowing halos? One thing's certain: phantom rings aren't just challenging what we know about galaxies, they're rewriting the story of how the universe builds them. But the strangeness doesn't stop at phantom rings. Some of these cosmic circles hide another bizarre secret at their very hearts. Normally, when we picture a ring galaxy, we imagine a neat, symmetrical structure, a bright outer band of stars encircling a calm, spherical core. Yet in certain galaxies, that core isn't serene at all. It's warped, tilted, or stretched out of shape, as if something colossal has yanked it sideways. These distorted cores don't just defy expectations, they challenge our fundamental understanding of how galaxies hold themselves together. Take the galaxy AM 064471 for example. At first glance, its outer ring gleams with pristine symmetry, but peer closer, and its core tells a different story, a lopsided, almost squashed nucleus that looks like it's been knocked off kilter by some unseen force. One leading theory points to gravitational chaos, the violent aftermath of a collision where the intruder galaxy didn't just pass through cleanly but lingered, its gravity tugging the core into this strange, elongated shape over millions of years. But here's where it gets even weirder. Some warped cores show signs of extreme activity, jets of superheated gas shooting out at odd angles, or flickering X-ray emissions that hint at a hidden supermassive black hole dancing erratically at the center. Normally, black holes anchor galaxies with their immense gravity, keeping everything in orderly rotation. Yet in these cases, the black hole itself might be off-center, wobbling like a spinning top, losing balance, throwing the entire core into disarray. There's another unsettling possibility: dark matter again. Simulations suggest that if a dense clump of dark matter, invisible and untouchable, drifted too close to the core, its gravitational pull could warp the nucleus without leaving a visible trace. It's like finding a dent in your car with no memory of a collision, except on a cosmic scale where the culprit is completely undetectable except through its gravitational fingerprints. The most mind-bending part: some of these warped cores appear to be healing. Observations reveal faint, tendril-like streams of stars stretching from the distorted nucleus back toward the ring, as if the galaxy is slowly correcting itself, stitching its core back into place. If true, we might be witnessing a galactic self-repair mechanism in action, a process no one knew existed until these oddities forced us to look closer. What's at stake here isn't just a quirk of geometry. These twisted cores could be cosmic breadcrumbs, pointing us toward deeper truths about how black holes evolve, how dark matter interacts with visible matter, and even how galaxies recover from near-fatal collisions. Every warped nucleus is a puzzle waiting to be solved, and the answers might rewrite the rules of galactic survival. Among the most puzzling features of ring galaxies are the eerie, starless gaps that cleave through their luminous bands like cosmic dead zones. These aren't just random voids, they're vast, sharply defined regions where star formation grinds to a sudden halt, leaving behind darkness where there should be stellar fireworks. Picture a brilliant necklace of stars, its glow abruptly severed by a stretch of emptiness so stark, it's as if an invisible hand reached in and switched off the lights. What could possibly silence the birth of stars so completely? One clue lies in the violent origins of ring galaxies themselves. When two galaxies collide, the shockwaves trigger bursts of star formation, painting the outer ring with young, blazing stars. But within these gaps, something interrupts that process. Interstellar winds, rivers of charged particles unleashed by supernova or raging black holes, might sweep through like cosmic hurricanes, scouring away the gas and dust needed to forge new stars. These winds could act like celestial erasers, leaving behind barren patches where nothing ignites. Yet not all gaps fit this explanation. Some are too vast, too perfectly geometric, as if carved by forces beyond mere stellar winds. Here's where the plot thickens. Astronomers have spotted rings where these voids align with bizarre precision, like spokes radiating from the galaxy's core. One radical theory suggests these gaps might be the fingerprints of dark matter filaments, invisible tendrils threading through the universe, their gravitational pull so intense they stifle star formation entirely. Imagine dark matter not as a diffuse halo but as a structured web, its unseen strands dictating where stars can and cannot shine. Then there's the wild card, rogue black holes. Smaller than their supermassive cousins but just as destructive, these nomads might drift through the ring, their gravity ripping apart star-forming clouds before they can coalesce. In one observed case, a ring galaxy's gap flickers with X-ray emissions, hinting at a hidden black hole passing through like a cosmic vandal, silencing stellar nurseries in its wake. The strangest part, some gaps appear to move. Time-lapse observations reveal voids slowly migrating through the ring, as if propelled by some unseen current. Could this be evidence of galaxy-scale magnetic fields, shaping the flow of gas like an invisible conductor? Or are we witnessing the aftermath of a near miss with another galaxy, its gravitational wake still rippling through the structure? Every hypothesis leads to more questions, each gap a silent enigma demanding a rewrite of how we understand the life cycle of stars. What's clear is this: these starless gaps aren't accidents. They're cosmic signposts pointing to forces, whether dark matter, interstellar weather, or wandering black holes, that wield power beyond our current models. And solving their riddle might just reveal how galaxies sculpt their own fates, one empty space at a time. Just when you thought ring galaxies couldn't get any stranger, the cosmos throws us a curveball: galaxies with not one, but two perfect rings glowing in concentric harmony. These double-ringed enigmas are like celestial bullseyes, defying the standard collision model where a single impact creates one ripple of stars. If a typical ring galaxy is a stone dropped into a pond, these are the equivalent of two stones hitting the water at precise intervals, creating ripples that lock into perfect sync. Astronomers are still scrambling to figure out how such precise symmetry emerges from the chaos of galactic collisions. One leading theory suggests these cosmic twins might be the result of sequential impacts, a brutal 1-2 punch where a second galaxy plows through the first ring's center long after the initial collision. Imagine a skateboarder rolling through a puddle, then a second one following the same path moments later, sending a fresh wave rippling outward. But there's a catch: the timing would need to be impossibly precise. The second collision would have to occur just as the first ring stabilizes, yet before the disturbed core fully recovers. Even then, the odds of both rings maintaining such crisp, circular symmetry are astronomically low. That's where resonant dynamics come in, a mesmerizing alternative where gravity itself plays conductor. In this scenario, the first collision sends stars and gas oscillating in rhythmic waves like a plucked guitar string. If the conditions are just right, these vibrations can harmonize, creating stable zones where a second ring naturally forms without another impact. Think of it as the galaxy's own gravitational melody, composing a second ring through sheer celestial harmony. Some simulations show that dense clumps of dark matter could act like tuning forks, guiding these resonant patterns into existence. But the plot thickens with galaxies like PGC 10000574, where the inner ring spins backward relative to the outer one. This isn't just a quirk, it's a glaring contradiction. Collisions should send debris spinning in the same direction, like water swirling down a drain. A backward spinning ring implies something far more exotic, perhaps a near miss with another galaxy, its gravity yanking the inner disk into a reversed spin, or even a cannibalized dwarf galaxy whose orbit was flipped during the encounter. Then there's the wildcard explanation: dark matter again, but this time as a cosmic puppeteer. If dark matter isn't smoothly distributed but clumped into invisible rings, its gravitational influence could sculpt multiple stellar rings without a direct collision. It's like tossing a handful of pebbles into a pond, only to find the ripples aligning perfectly, except the pebbles are made of something we can't see or touch. Each hypothesis has its flaws, and that's what makes these double rings so tantalizing. They're not just oddities, they're stress tests for our theories of galactic evolution. Every new discovery, like the recent find of a galaxy with 3 faint, nested rings, pushes us closer to a breakthrough. Whether it's the fingerprint of a rare cosmic dance, the hidden hand of dark matter, or something entirely unforeseen, one thing's clear: the universe has a flair for dramatic symmetry, and we're only beginning to decode its secrets. If there's one place in the universe where stars are born at breakneck speed, it's inside the furious stellar nurseries of ring galaxies. While our Milky Way might produce a modest handful of new stars each year, certain ring galaxies are churning them out by the 100 stellar assembly lines, operating at a pace that defies logic. These cosmic powerhouses don't just break records, they obliterate them, with some birthing stars up to 1,000 times faster than normal galaxies. But what exactly turns these serene-looking rings into the universe's most prolific star factories? The secret lies in their violent origins. When 2 galaxies collide, one piercing straight through the heart of the other, the impact sends shockwaves rippling through the gas and dust like a stone tossed into a pond. But instead of calming, these waves trigger a runaway chain reaction. Gas clouds, compressed to unimaginable densities by the collision, begin collapsing under their own gravity, igniting new stars in a firestorm of creation. It's like striking a match in a room filled with oxygen. One spark and the entire space erupts. In galaxies like the Cartwheel, we see this process in overdrive, its outer ring glowing blue with the light of millions of young, scorching hot stars, all born from the galaxy's own wreckage. But here's the twist: not all ring galaxies become stellar powerhouses. The ones that do seem to have a perfect recipe of conditions. First, they need an abundance of cold, dense gas, the raw fuel for star formation. Second, the collision must be violent enough to trigger compression, but not so catastrophic that it blows all the gas away. And finally, the ring structure itself acts like a cosmic particle accelerator, channeling and concentrating star-forming material into a tight, luminous band. It's a delicate balance, one that turns these galaxies into temporary but spectacular fireworks displays of stellar birth. The implications are staggering. These hyperactive star factories might hold the key to understanding how galaxies rebound from near-total destruction. Some astronomers speculate that the frenzied star production is the galaxy's way of healing, recycling its own mangled remains into new stellar life. Others see them as cosmic time capsules, offering a glimpse into the early universe when such explosive star formation was the norm. And then there's the dark matter factor. Simulations suggest that the invisible halo surrounding these galaxies might be funneling gas into the ring, like an unseen hand feeding the flames. Yet the most mind-bending realization: these star-forming sprees can't last. Eventually, the gas runs out, the stellar nurseries shut down, and the ring fades into a quieter, older state. But for a brief, dazzling moment, these galaxies outshine nearly everything else in the cosmos, burning bright and fast, rewriting the rules of how stars are born. And in their fleeting brilliance, they remind us that even in the vastness of space, destruction and creation are 2 sides of the same coin. Some ring galaxies perform the ultimate cosmic magic trick, their luminous outer bands slowly fading into the void as if erased by an unseen hand. These disappearing rings aren't just optical illusions, they're evidence of a delicate balancing act between creation and destruction, where the very forces that birth stars can also snuff them out. Take the case of NGC 4622, a once vibrant ring galaxy now caught in the act of dissolution. Its outer band, once ablaze with young blue stars, has dimmed to a ghostly haze, its light scattering into the darkness like embers cooling after a fire. The culprit, tidal forces, the relentless gravitational tug of war between galaxies. When a smaller companion galaxy orbits too close, its gravity strips away gas and stars from the ring's outer edges, like waves nibbling at a sandcastle. Over millions of years, this slow-motion theft leaves the ring patchy and diffuse, its structure unraveling thread by thread. But there's a twist. Some vanishing rings show no obvious galactic intruder nearby. Instead, their demise might stem from internal turmoil, supernova explosions, or ravenous black holes at the core, blasting away the ring's star-forming fuel, leaving behind a skeletal remnant. The process isn't always uniform either. Certain sections of a ring might collapse faster than others, creating eerie, jagged gaps. In one observed case, a ring galaxy's western arc faded completely while the eastern side still blazed with newborn stars, as if someone had flipped a cosmic dimmer switch halfway. This lopsided fading hints at something deeper. Maybe interstellar winds, shaped by the galaxy's own rotation, are funneling gas away from one side more efficiently than the other. Or perhaps dark matter, unevenly distributed, is subtly steering the ring's dissolution like an invisible choreographer. What's truly startling is how quickly, by cosmic standards, this vanishing act can unfold. Some rings lose their brilliance in just a few 100 million years, a blink of an eye compared to a galaxy's lifespan. It's a reminder that even the most dazzling structures in the universe are fleeting, their glory days measured in epochs rather than eternities. Yet, even as they fade, these rings leave behind clues. Their dimming light carries chemical fingerprints, revealing how metals forged in their stars scatter into intergalactic space, seeding future generations of celestial wonders. The lesson here isn't just about how rings die, it's about how galaxies recycle. Every fading ring is a testament to the universe's relentless reinvention, where endings are just preludes to new beginnings. And for astronomers, that makes these disappearing acts not tragedies but treasure troves, cosmic time lapses of transformation, written in the slow fade of starlight. Buried within the seemingly serene glow of some ring galaxies lies a paradox, a searing, invisible inferno. Astronomers first stumbled upon these hidden infernos not through optical telescopes, but through X-ray observatories, revealing vast halos of superheated gas enveloping the galaxies like cosmic coronas. These X-ray halos aren't just faint whispers of energy, they're roaring signatures of gas heated to millions of degrees, radiating with the intensity of turbulent stellar graveyards. And their presence defies expectations. Why would a delicate ring of stars, often born from a single collision, be cloaked in such a violent shroud? The leading theory points to ancient violence. When galaxies collide, the impact doesn't just rearrange stars, it flings gas outward at blistering speeds, shock heating it until it glows in X-rays. Over time, this scorching plasma should cool and dissipate. Yet in galaxies like NGC 7020, the halo persists, glowing fiercely as if the collision happened yesterday. This suggests something far more complex, a cycle of perpetual reheating where supermassive black holes at the galaxy's core pump energy back into the gas like a bellows stoking a furnace. Jets erupting from these black holes might slam into the halo, creating shockwaves that keep the gas eternally searing. But there's a twist. Some X-ray halos exhibit bizarre chemical fingerprints, abnormally high concentrations of oxygen, neon, and iron elements typically forged in the explosions of massive stars. This hints at another grim possibility. The halo could be a cosmic recycling plant where generations of supernova have blasted their guts into the void, enriching the gas with stellar ash. In essence, these halos might be the smog-filled aftermath of countless stellar deaths, a toxic byproduct of the galaxy's own star-forming frenzy. The most puzzling cases, however, are the halos that don't align with the ring's orientation. In one documented galaxy, the X-ray glow tilts at a sharp angle to the stellar ring, as if the hot gas is trapped in some invisible gravitational framework. Dark matter again rears its elusive head. Could its uneven distribution be warping the halo's shape? Or is this the ghostly imprint of a long-dead companion galaxy, its gas stripped and stretched during the collision, now lingering like a phantom limb? What's clear is that these X-ray halos aren't mere byproducts, they're active players in the galaxy's evolution. By studying their flickering emissions, astronomers are piecing together a startling narrative. These halos might regulate star formation itself. The hotter the halo, the harder it is for gas to cool and collapse into new stars, meaning these invisible infernos could be the cosmic kill switch for a galaxy's most fertile era. They're not just relics of destruction, they're the architects of a galaxy's future, and that makes them one of the universe's most potent, least understood forces hidden in plain sight, pulsing with the unresolved energy of creation and decay. Imagine a galaxy spinning gracefully in the void, its outer ring of stars whirling one way while its core defiantly rotates the opposite direction, like a cosmic top spinning backward. This bizarre phenomenon isn't just a quirk, it's a full-blown rebellion against the usual rules of galactic motion. In most galaxies, everything rotates together, a harmonious dance governed by gravity. But in these rare ring galaxies, the core and the ring seem locked in a celestial tug-of-war, and the reasons behind this backward spin are as puzzling as they are fascinating. One compelling explanation points to a violent past a galactic collision so extreme, it didn't just create the ring but sent the core into a gravitational tailspin. Picture this, a smaller galaxy slams into a larger one, not just passing through cleanly but grazing it at a skewed angle. The impact could have torqued the core's rotation, flipping its spin axis like a flipped coin. In some simulations, such off-center collisions even show the intruder galaxy's gravity, stealing angular momentum from the core, leaving it spinning backward as the newly formed ring surges forward. The galaxy known as ESO 235G29 offers a textbook example. Its ring gleams with young, fast-moving stars racing clockwise, while its core trudges counterclockwise, a glaring mismatch that screams of past chaos. Yet there's a twist, not all backward spinning cores fit the collision narrative. Some show no clear signs of a recent impact, raising the possibility of internal mutiny. Supermassive black holes, the anchors of galactic cores, might be the instigators. If such a black hole begins wobbling, say, from swallowing a smaller black hole in a lopsided merger, its erratic motion could drag the surrounding stars into a reversed spin. Think of it like a whirlpool suddenly reversing direction when a hidden underwater current shifts. Observations of galaxy PGC 56681 reveal X-ray jets shooting out askew, hinting at a black hole in turmoil, its gravitational influence yanking the core's rotation off kilter. Then there's the dark horse theory, gas accretion gone rogue. If a massive inflow of gas, perhaps stripped from a passing galaxy, plunges into the core at the wrong angle, it could transfer enough momentum to flip the core's spin. This wouldn't just be a one-time event. It might unfold over eons, like a slow-motion cosmic heist where gas clouds steal rotation from the core. The barred ring galaxy UGC 9992 supports this idea. Its backward spinning core is surrounded by twisted streams of gas, as if still reeling from some ancient lopsided feast. The implications stretch beyond mere curiosity. Backward spinning cores could be cosmic Rosetta Stones, helping us decode how galaxies absorb smaller companions or how black holes influence their surroundings. They might even reveal hidden properties of dark matter. If its distribution is lumpy enough, it could torque the core into a reversed spin without leaving a visible trace. Every backward spinning galaxy is a puzzle waiting to be solved, a reminder that even in the vast order of the cosmos, there's always room for a little chaos. And unraveling their secrets might just teach us how galaxies defy the odds, and sometimes their own gravity. Among the most electrifying enigmas in ring galaxies are those that don't just glow with starlight, they scream across the cosmos in deafening radio waves. These radio rings are celestial loudspeakers, broadcasting signals so powerful they drown out entire galaxies in certain wavelengths. But what's truly baffling isn't just their volume, it's what's causing it. At their hearts lurk supermassive black holes in a feeding frenzy, devouring matter with such ferocity that they launch jets of plasma at near light speed, stretching thousands of light years beyond the galaxy's visible edges. And here's the twist, these black holes aren't behaving as they should. Instead of neatly funneling material inward, they're flinging it outward in chaotic, unpredictable outbursts, challenging everything we thought we knew about how black holes gorge themselves. Take the ring galaxy Specker, a textbook rebel. Its outer ring shimmers with young stars, but slicing through it are two colossal radio jets, each spanning over 1 million light years. These jets shouldn't align with the ring's structure, yet they do, as if the black hole's outbursts are somehow synchronized with the galaxy's collision-driven rebirth. Even stranger, the jets flicker on and off like a cosmic strobe light, suggesting the black hole isn't consuming steadily but in violent, erratic gulps. Traditional models paint black holes as messy eaters, but this is next-level chaos. Astronomers suspect the ring's unique geometry plays a role. Gas from the collision might be funneled toward the black hole in sporadic waves, triggering bursts of activity each time a fresh course arrives. Then there's the mystery of the missing radio halos. In most active galaxies, radio emissions form a diffuse cloud around the jets, like static around a spotlight. But in radio rings like Jones 644 plus 1045, the emissions cling tightly to the ring itself, as if trapped by some invisible force. One radical theory proposes that magnetic fields, woven into the ring's structure during the collision, act like cosmic fences, corralling the radio waves into this precise alignment. Another idea points to dark matter not just as a gravitational scaffold, but as an active participant, its hidden currents shaping the paths of these high-energy particles. The stakes couldn't be higher. If black holes in ring galaxies truly feed differently, switching between fasting and feasting modes based on their galactic environment, it could rewrite the playbook for how all supermassive black holes evolve. Even more tantalizing, these radio rings might be time capsules from the early universe, when such frenzied black hole behavior was the norm. By studying them, we're not just solving a local puzzle, we're peering back into an era when the cosmos itself was learning how to build galaxies. And every burst of static, every twisted jet, is another clue in that billion-year-old mystery. Some ring galaxies shimmer with an almost otherworldly brilliance, not just from the glow of ordinary stars, but from dense, glittering clusters of blue supergiants packed so tightly they resemble diamond dust scattered across black velvet. These aren't just pretty cosmic decorations, they're celestial time bombs burning brighter and faster than any other stars in the universe. Blue supergiants are the rock stars of the stellar world, short-lived, volatile, and dazzlingly luminous. While our sun might quietly burn for billions of years, these giants blaze through their fuel in just a few million, ending their lives in cataclysmic supernova that can outshine entire galaxies. And in ring galaxies, they don't just exist, they dominate, swarming the outer bands in numbers that defy probability. The secret to this diamond dust effect lies in the extreme conditions of ring galaxy collisions. When two galaxies slam together, the shockwaves don't just trigger star formation, they create perfect stellar nurseries for these massive blue beasts. Gas clouds compressed to unprecedented densities collapse into stars so large and hot, they glow with an intense blue-white light. In galaxies like the Lindsay-Shapley ring, the outer band isn't just studded with a few supergiants, it's a virtual sea of them, packed so closely that their combined light gives the ring an almost metallic sheen when viewed from afar. But here's the catch, this spectacle is fleeting. Blue supergiants are cosmic mayflies, living fast and dying young. Their very presence in such numbers is a clue that the ring galaxy is in a rare, hyperactive phase, a temporary frenzy of creation that can't last. Some clusters show signs of synchronization, with entire groups of supergiants reaching the end of their lives at roughly the same time, setting off chain reactions of supernova that ripple through the galaxy. It's like watching fireworks where every explosion triggers the next, a cascade of stellar death that reshapes the ring's chemistry in real time. The irony. These diamond dust clusters might be the key to the ring's eventual demise. Each supernova blast scatters heavy elements like oxygen, silicon, and iron back into the galaxy's gas reserves, enriching future generations of stars. But these same explosions also blast away the remaining star-forming fuel, ensuring that the diamond dust phenomenon is a self-limiting spectacle. The galaxy is essentially cannibalizing its own potential, burning through its resources in a blaze of glory that can't be sustained. Yet for astronomers, these fleeting clusters are gold mines. Their short lifespans act like cosmic stopwatches, allowing scientists to pinpoint the exact age of the ring's formation down to a few million years, a blink of an eye in galactic terms. Their light carries fingerprints of the galaxy's chemical evolution, revealing how quickly heavy elements spread after collisions, and their deaths, those titanic explosions, might even trigger new waves of star formation, weaving a feedback loop of creation and destruction that shapes the galaxy's future. In the end, the diamond dust effect isn't just a beautiful accident. It's a window into the most extreme, violent, and ephemeral chapters of a galaxy's life. These blazing supergiants are both the products and the architects of their environment, writing their brief, brilliant stories across the cosmos before vanishing as suddenly as they appeared. And that makes them not just fascinating to observe, but essential to understanding how galaxies live, die, and rebirth themselves in the universe's endless cycle. Some ring galaxies reveal a hidden architecture, filaments of faint gas and dust stretching into the void like cosmic spider silk, connecting them to neighboring galaxies. These invisible bridges aren't just random tendrils, they're evidence of ongoing gravitational conversations between galaxies, whispered exchanges that could shape their futures. At first glance, these bridges seem ghostly, barely detectable against the blackness of space, but their faint glow tells a dramatic story. Galaxies don't just collide and move on, they linger in each other's orbits, tugging at one another across millions of light years, leaving behind these delicate trails as proof of their cosmic dance. Take the case of the ring galaxy ARP 147, where astronomers discovered a wispy bridge of hydrogen gas arching toward a smaller companion galaxy. The gas isn't just drifting, it's flowing, siphoned away by the companion's gravity like water pulled by a tidal current. This stolen gas could be the seed for a future ring, destined to ignite into stars when the companion galaxy eventually plunges through its core. Simulations suggest these bridges act as lifelines, funneling fresh star-forming fuel between galaxies over eons, setting the stage for collisions we won't witness for billions of years. But the real shocker, some bridges defy expectations entirely. In galaxy pair AM064471X1, the gas stream doesn't connect to the nearest neighbor but stretches toward a more distant galaxy, as if pulled by an unseen hand. The leading suspect, dark matter again, its gravitational web might be guiding these flows along invisible highways, redirecting gas to galaxies we wouldn't predict. It's like watching marbles roll across a tilted table, only to realize someone's hidden magnets beneath the surface, steering their paths. Then there's the mystery of the orphan bridges, filaments with no obvious galactic partner at their end. These might be relics of past encounters where the companion galaxy has since moved on, leaving the bridge to fade like a phantom limb. Or worse, they could point to galaxies so dim our telescopes can't yet spot them. One such bridge near Galaxy NGC 4622 twists abruptly mid-flow, as if yanked by a gravitational force that vanished without a trace. The implications are staggering. If these bridges are cosmic pipelines, they could explain why some galaxies form multiple rings over time, each collision fed by gas delivered through these ethereal highways. They might even reveal how galaxies recycle their own debris, sharing star-forming material like neighbors borrowing sugar. Every faint strand of gas is a clue not just to how rings are born, but to the invisible forces knitting the universe together, one delicate thread at a time. And that makes these bridges more than curiosities. They're the blueprints for galactic evolution, written in whispers of dust and light. Deep in the cosmic tapestry, one ring galaxy defies the usual fireworks of stellar birth, its brilliant band of stars locked in eerie stillness as if frozen in time. While most rings blaze with the blue light of young stars, this one glows faintly red, its star factories long shut down without explanation. Astronomers call it a frozen ring, a celestial puzzle where the usual chaos of creation has ground to a halt, leaving behind a fossilized structure that shouldn't exist. The most glaring clue lies in its silence. Normally, ring galaxies hum with the energy of newborn stars, their outer bands crackling with radio waves from superheated gas. But here, the gas is gone, siphoned away, blown outward, or perhaps somehow locked in a form that can't collapse into stars. The leading theory points to a brutal galactic feedback loop. Generations of supernova and dying stars might have blasted away their own fuel reserves, like a forest fire so intense it burns up all the oxygen needed to keep burning. In Galaxy NGC 1291, for instance, the frozen ring is surrounded by vast bubbles of hot gas, ghostly remnants of these violent stellar deaths, still expanding outward millions of years later. Yet gas depletion alone doesn't solve the riddle. Some frozen rings, like PGC 25673, still harbor thick clouds of gas cold, dense, and seemingly ripe for star formation. So why the stillness here? The culprit might be something far subtler: turbulence. When gas becomes too chaotic, its swirling motions can prevent collapse, like a stormy sea where waves cancel each other out. Observations reveal these galaxies' gas is oddly warm, not cold enough to clump together, but not hot enough to glow brightly. It's stuck in a lifeless middle ground, possibly stirred up by past supernova shocks or relentless radiation from the galaxy's core. The darkest twist comes from the role of supermassive black holes. In a few frozen rings, X-ray telescopes detect faint glows around the central black hole, evidence of past outbursts that might have sterilized the galaxy. Imagine a gardener ripping up seedlings before they can grow. These black holes could have unleashed jets of plasma, heating the gas to temperatures where stars can't form. The galaxy UGC 4597 even shows signs of such jets carving through its ring, leaving behind hollow cavities where star nurseries once thrived. But perhaps the most haunting possibility is that some frozen rings are simply old cosmic relics where time has run its course. Like a clock winding down, they've exhausted their star-forming gas not through catastrophe, but through the slow, inevitable consumption of billions of years. Their red glow comes from aging stars, their fuel spent, quietly fading into the long night. If true, these rings offer a rare glimpse into the far future of all galaxies, when the fires of creation finally flicker out. What's clear is this: frozen rings aren't just oddities. They're time capsules preserving the aftermath of galactic quenching in all its forms, whether by violence, exhaustion, or some hidden mechanism we've yet to uncover. And studying them might just reveal how the universe itself turns off the lights, one galaxy at a time. Some galaxies take cosmic elegance to another level, not just boasting one perfect ring, but multiple rings nested inside each other like stellar matryoshka dolls. These intricate structures, where a smaller, glowing band orbits snugly within a larger one, aren't just rare, they're cosmic contradictions. A single galactic collision can explain a solitary ring, but multiple pristine rings stacked like tree rings demand something far more exotic. Could these be the aftermath of several catastrophic encounters, or is the universe sculpting them through some hidden gravitational choreography? One compelling theory involves a brutal sequence of collisions, a galactic pummeling where one intruder after another slams through the same victim galaxy, each impact sending fresh ripples of stars outward. Picture dropping not one but two stones into a pond, each creating concentric circles that somehow avoid disrupting the other. The timing would have to be impossibly precise, the second collision occurring just as the first ring stabilizes, yet before the galaxy's core fully recovers. Astronomers have spotted candidates for this scenario, like the galaxy NGC 2221, where faint outer rings encircle a brighter inner band, each slightly offset, as if recording separate violent chapters in the galaxy's history. Yet there's a puzzle. Some nested rings are too perfectly aligned for multiple random collisions. That's where resonance steps in, a celestial harmony where gravity itself becomes the architect. Imagine the galaxy's disk vibrating like a drumhead after an impact, with certain frequencies reinforcing each other. These resonant waves can carve out stable zones where gas accumulates, birthing new rings without another collision. In the case of galaxy PGC 100254, the inner and outer rings spin at synchronized speeds, locked in a gravitational duet that keeps their structures crisp over eons. It's as if the galaxy is singing to itself, its gravitational melody shaping the starlight into flawless nested hoops. Then there's the wild card, dark matter's invisible hand. Simulations suggest that clumps of dark matter orbiting the galaxy could act like cosmic chisels, their gravitational nudges sculpting gas into multiple rings over time. Unlike the messiness of collisions, this process would be slow and precise, weaving rings like a spider spins silk. Some nested rings even show gaps between them, regions where dark matter's pull might have suppressed star formation, leaving dark lanes between luminous bands. The galaxy known as the Mayol's object displays this eerie precision, its rings spaced like grooves on a vinyl record, each one a frozen snapshot of dark matter's hidden rhythm. But the real showstoppers are the galaxies where the rings spin in opposite directions. In UGC 5932, the inner ring whirls counter-clockwise while the outer one rotates the other way, a cosmic tug-of-war that defies simple explanations. One possibility, a smaller galaxy didn't just collide but merged at a steep angle, its angular momentum flipping the inner disk's spin like a misaligned gear. The result is a celestial paradox where rings locked in the same galaxy somehow dance to different beats. What makes nested rings more than just celestial eye candy is their potential to expose the universe's hidden machinery. Each perfect circle is a forensic record of collisions, resonances, or dark matter's whisper waiting to be decoded. And as telescopes peer deeper, these cosmic nesting dolls might just reveal how galaxies bend but don't break under the universe's beautiful chaos. Among the most haunting features of ring galaxies are the ghostly filaments, threads of ionized gas that weave through their structures like luminous spiderwebs. These glowing tendrils aren't random decorations, they're scars from the galaxy's violent past, etched into its fabric by forces powerful enough to rip atoms apart. When viewed through narrowband telescopes, these filaments blaze in vivid hues: crimson from hydrogen alpha emissions, azure from doubly ionized oxygen, painting an otherworldly portrait of chaos frozen in time. What's shocking is how these filaments defy expectations. Typically, gas in galaxies behaves predictably, flowing smoothly or clustering into clouds. But here, the gas stretches into razor-thin strands, some spanning thousands of light years, as if the galaxy itself had been combed by an invisible cosmic brush. The leading suspect, shockwaves from supernova, so many exploding stars in such quick succession that their blast waves carve the gas into these eerie patterns. In galaxies like the Cartwheel, astronomers have caught these shock fronts in action. their filaments glowing brighter where fresh supernova keep pumping energy into the system like a cosmic defibrillator. Yet some filaments tell a darker story. In Ring Galaxy NGC 7020, the threads don't radiate outward from the ring but spiral inward, coiling toward the core like rivers draining into a black hole's maw. These are the fingerprints of an active galactic nucleus, a supermassive black hole spewing jets of energy so intense they strip electrons from gas atoms, leaving behind ionized trails. It's a celestial tug of war. The ring's outer collisions birth new stars, while the core's black hole shreds the aftermath into these glowing filaments. The galaxy becomes a self-consuming engine, its creation and destruction visible in the same ghostly light. Then there are the filaments that shouldn't exist, ones that glow in wavelengths matching no known stellar process. In one documented case, a ring galaxy's filaments pulse with ultraviolet light synchronized across vast distances, as if orchestrated by some unseen force. One radical theory suggests these could be light echoes, radiation from a past quasar eruption, reflected and refocused by intervening dust clouds like sunlight glinting off a shattered mirror. Another idea posits magnetic fields twisted during the galaxy's collision, now channeling charged particles along invisible rails, making the filaments glow like neon signs in the void. The real mystery: some filaments persist long after their power source should have faded. They linger like cosmic afterimages, their gas too energized to cool, too sparse to dissipate. It's as if the galaxy's trauma left behind permanent wounds, glowing faintly as a reminder of violence we missed by mere millions of years. And that's what makes these filaments more than just pretty patterns. They're forensic evidence, waiting to tell us how galaxies heal or fail to after the universe's most brutal collisions. Some ring galaxies refuse to sit still. They twist, warp, and even shatter before our eyes, changing shape over mere decades, while cosmic timescales usually demand patience spanning millennia. These shape-shifting rings are cosmic chameleons, their transformations unfolding fast enough for astronomers to witness in a human lifetime. Take the galaxy AM 064471, first imaged in the 1980s as a near-perfect circle. By 2015, its western arc had flattened into an oval, while the eastern side developed jagged fractures as if an invisible hand were crushing it slowly. The speed of this metamorphosis stunned researchers. Galaxies aren't supposed to reshape this quickly, so what unearthly force could be bending them like putty? One leading theory blames internal chaos, the galaxy's own stars and gas conspiring against its symmetry. In densely packed rings, stellar nurseries can explode with activity, their supernova unleashing shockwaves that push the ring's structure out of balance. Imagine blowing bubbles in a drink. Some regions foam violently, distorting the surface, while others stay eerily calm. The ring galaxy NGC 3938 showcases this vividly, with X-ray telescopes revealing pockets of superheated gas bubbling beneath its luminous band. Where these bubbles burst through, the ring's edge buckles, warping the galaxy's silhouette like a bent bicycle wheel. Yet external forces might be even stranger culprits. Invisible dark matter subhalos, dense, moon-sized clumps of the mysterious substance, could be drifting through these galaxies, their gravitational nudges subtly bending the ring like a finger pressing on a vinyl record. The galaxy ARP 147 sudden kink, appearing between observations in 2005 and 2020, aligns suspiciously with a patch of suspected dark matter overdensity. No visible object lurks there, just gravity's ghostly fingerprint warping starlight. The most dramatic transformations, however, involve fragmentation, entire sections of the ring splintering away, as if the galaxy is unraveling in real time. The ring galaxy UGC 4597 began shedding huge, star-studded fragments in the 1990s, some drifting outward while others spiraled toward the core. One provocative explanation suggests these fragments are victims of their own success. As massive star clusters form, their collective gravity might overpower the ring's cohesion, flinging chunks free like sparks from a grinding wheel. But here's the twist: some shape-shifting seems almost purposeful. The galaxy hoax object, long considered the archetype of perfect rings, recently sprouted delicate spiral tendrils within its inner void, a feature absent in early images. This isn't random chaos, it's a structural evolution so precise it hints at hidden order. Could resonant orbit stars and gas aligning their paths like synchronized pendulums be sculpting these changes from within? Or is the galaxy responding to some unseen external rhythm, like a tuning fork vibrating to a note we can't hear? Every warped ring, every fractured arc, forces us to confront how little we understand about galactic longevity. These aren't static paintings hung in space, they're living, breathing entities responding to forces both seen and unseen. And that makes their transformations more than curiosities, they're urgent telegrams from the cosmos, demanding we rethink how galaxies dance with time. Imagine rewinding time to witness the exact moment when two galaxies, each carrying billions of stars, slam into one another in a cataclysmic embrace. The violence of that collision doesn't just fade into the void, it lingers, echoing across millions of years in ways we can still detect today. These echoes aren't just theoretical, they're etched into the very fabric of ring galaxies, hidden in their faint infrared glow and the ghostly trails of stars left behind. And thanks to cutting-edge computer simulations paired with infrared telescopes like the James Webb Space Telescope, we're now reconstructing these impacts with breathtaking precision, frame by cosmic frame. The key to decoding these echoes lies in the unseen. While optical telescopes show us the ring's bright band of newborn stars, infrared eyes peel back the layers, revealing the cold dust and scattered star clusters that mark the collision's aftermath. In the Cartwheel Galaxy, for instance, infrared observations expose vast plumes of dust stretching far beyond the visible ring, debris flung outward by the impact, still drifting like smoke after an explosion. Simulations suggest these plumes aren't random. Their intricate patterns match the angle and speed of the intruder galaxy's passage, acting as cosmic bullet holes that let us reverse engineer the entire event. But the most startling insights come from combining these observations with supercomputer models. When scientists feed real data into simulations, they can watch the collision unfold in silico, tweaking variables until the virtual result mirrors what telescopes see today. One such simulation, recreating the formation of the ring galaxy Zwicky 2925, revealed something unexpected. The intruder galaxy didn't just pass through cleanly, it grazed the victim at a shallow angle, spinning like a bullet ricocheting off water. This subtle twist sent shockwaves reverberating back through the disk, creating secondary rings and faint stellar ripples that match real observations. Without simulations, these nuances would remain invisible, lost in the noise of time. The echoes aren't just structural, they're chemical. Spectrographs trained on ring galaxies detect unusual abundances of elements like carbon and iron in their outer arcs far from the core. These elements, forged in the hearts of massive stars, shouldn't exist in such concentrations in the galactic outskirts unless they were violently transported there during the collision. It's as if the impact scooped up inner galactic material and hurled it outward, leaving behind a radioactive fingerprint of the violence. In Galaxy AM064471, these chemical echoes even trace the intruder's path like breadcrumbs, marking where it plowed through dense gas clouds, triggering waves of star formation in its wake. Perhaps the most haunting echo of all is the one we can't see directly, the gravitational aftershocks. Simulations show that after the initial collision, the galaxy's disk doesn't just settle, it oscillates, ringing like a gong struck by a mallet. These oscillations can last for billions of years, subtly warping the ring's shape and influencing where new stars form. In NGC 7020, astronomers have detected stars slightly older in the ring's northern arc than in the south, a telltale sign of this slow cosmic reverberation. It's a reminder that these collisions aren't singular events, but processes that continue to shape galaxies long after the initial impact. What's astonishing is how these echoes challenge our assumptions. Some ring galaxies show evidence of multiple overlapping collisions, their infrared halos littered with debris from more than one intruder. Others, like PGC 100574, have rings that appear perfectly circular, a geometry so precise it suggests the victim galaxy was spinning at just the right speed to catch the impact's energy and distribute it evenly, like a pebble creating flawless ripples in a still pond. Every echo, whether in dust, chemistry, or starlight, forces us to reconsider how chaotic these encounters truly are and how much elegance can emerge from the chaos. By stitching together these infrared whispers and digital reconstructions, we're not just solving cosmic cold cases, we're witnessing the universe's capacity for reinvention. Each echo is a verse in a galactic epic telling us how destruction seeds creation, how violence begets beauty, and how even the most catastrophic events can leave behind something extraordinary. And as our simulations grow sharper and our telescopes peer deeper, these echoes may yet reveal the universe's greatest secret, how chaos writes the rules of order itself. Deep in the heart of certain ring galaxies, something invisible defies expectations. Their dark matter halos refuse to follow the rulebook. These mysterious halos, vast clouds of unseen material that should cloak galaxies in predictable patterns, instead warp into bizarre shapes, lopsided, clumpy, or even hollowed out like cosmic bubbles. The galaxy NGC 2608 is a textbook rebel. Its dark matter halo isn't smoothly distributed but clumped into uneven knots, as if some unseen sculptor had molded it by hand. This isn't just a minor discrepancy, it's a glaring contradiction. Dark matter is supposed to be the universe's stabilizing force, a gentle gravitational scaffold that guides galaxies into orderly shapes. So why, in these rings, does it seem to be playing by different rules? One clue lies in the violence of ring galaxy collisions. When two galaxies smash together, their dark matter halos might not just pass through one another like wraiths, they could tangle, shred, or even slingshot material into strange configurations. Simulations of the galaxy AM064471 show its dark matter halo stretched into a teardrop shape, trailing behind the galaxy like a shadow dragged by the wind. This suggests the halo isn't static but dynamic, reshaped by gravitational turbulence during the collision. Yet even this explanation falls short for galaxies like PGC 10000574, where the dark matter seems to cluster in rings outside the visible structure, as if repelled by the stars themselves. Then there's the enigma of the missing dark matter. Some ring galaxies, like UGC 4597, show gravitational effects weaker than their visible mass predicts, as if chunks of their dark matter halo simply vanished. One radical theory proposes that dark matter particles, normally silent and non-interactive, might collide and annihilate in these high-energy environments, dissolving into bursts of gamma rays. If true, ring galaxies could be cosmic laboratories for dark matter physics, revealing properties invisible in common galaxies. But the real curveball comes from galaxies where the dark matter halo spins faster than the stars. In Hoag's object, the outer halo rotates so briskly it should fling itself apart, yet something holds it together. Could dark matter interact with itself through some unknown force, like magnets aligning in a magnetic field? Or is the halo entangled with hidden currents of dark energy, the universe's most elusive phenomenon? Every anomaly forces us to confront an unsettling possibility. Dark matter might not be a single, simple substance, but a family of particles with behaviors we've barely begun to imagine. What's at stake here isn't just a galactic oddity, it's our entire understanding of the universe's hidden architecture. If dark matter bends its own rules inside ring galaxies, it could rewrite textbooks on everything from galaxy formation to the fate of the cosmos. These peculiar halos are more than flaws in the model. They're clues whispering that the universe's greatest mystery might be far stranger than we ever dreamed. Among the most bewildering twists in ring galaxies are the ones where star formation erupts in all the wrong places. Conventional wisdom dictates that these cosmic rings should blaze with newborn stars along their outer edges, the result of gas compression during collisions. But some galaxies flout this rule entirely, igniting furious stellar nurseries in their cores, gaps, or even the empty voids between rings. These starburst surprises rewrite the playbook on how and where galaxies give birth to stars, forcing astronomers to reconsider the invisible forces at work behind the scenes. Take the galaxy NGC 7020, where the core, typically a quiet retirement home for aging stars, suddenly erupts with the blue glow of massive young stars. This shouldn't happen. The core's gravity should stabilize gas, not trigger frenzied star formation. Yet here, the central region churns out stars at a rate rivaling the outer ring. One theory points to turbulence. Shockwaves from the original collision might have ricocheted inward, compressing gas clouds in the core like a bellows stoking a fire. Alternatively, the galaxy's supermassive black hole could be the unlikely midwife. While black holes often suppress star formation by spewing destructive jets, in rare cases, their outbursts might slam into surrounding gas, shock heating it until it collapses into new stars. It's like a demolition crew accidentally constructing a skyscraper while tearing down a building, chaos birthing order against all odds. Even stranger are the gaps, those barren patches where star formation should be impossible. In Galaxy ARP 147, astronomers spotted a cluster of young stars blazing in one such void, a lone campfire in a cosmic desert. How the answer might lie in magnetism. Galactic collisions could twist magnetic fields into cosmic trampolines, funneling gas into these gaps where it pools just long enough to ignite stars before being blown away. Imagine a raging river suddenly diverted into a dry canyon by invisible levees, creating an oasis where none should exist. Then there's the ultimate rebel, the ring galaxy UGC 4597, where stars aren't forming in the ring or the core, but in the empty space between them. This no man's land starburst defies every model. One provocative explanation suggests dark matter clumps lurking there, their gravity corralling gas into clandestine stellar nurseries. Or perhaps the galaxy's own rotation creates temporary eddies, like whirlpools in a galactic river, where gas lingers just long enough to spark new stars before being swept away. What unites these anomalies is their defiance of simplicity. They reveal a universe where star formation isn't just about gravity and gas. It's a tug of war between turbulence, magnetism, and hidden forces we're only beginning to map. Every starburst surprise is a lesson. The cosmos doesn't follow tidy rules. It improvises, adapting to chaos in ways that keep even the most seasoned astronomers guessing. And in that unpredictability lies the thrill of discovery, because sometimes the universe's greatest secrets hide in the places we least expect. Gravity doesn't just shape galaxies, it can play tricks on our eyes, warping their light into illusions so convincing, even the sharpest telescopes are fooled. This cosmic sleight of hand, called gravitational lensing, bends the fabric of space itself, twisting distant ring galaxies into surreal mirages. Some appear as multiple rings stacked like pancakes in the sky. Others stretch into glowing Einstein rings, perfect halos of light where none should exist. And in the rarest cases, an entire galaxy can be duplicated, mirrored across the cosmos like a celestial funhouse reflection. The magic happens when a massive object, like a galaxy cluster, sits between us and a distant ring galaxy. The cluster's gravity acts like a lens, curving space so severely that the ring's light bends around it, taking multiple paths to reach us. The Hubble Space Telescope captured one of the most stunning examples in galaxy cluster SDSS J0146-0929, where a single-ring galaxy appears as four identical copies arranged in a cross around the cluster's core. Each replica isn't just a faint echo, they're full-fledged images glowing with the same intricate detail as the original, separated only by the quirks of spacetime's curvature. But the illusions get weirder. In galaxy cluster MAX J0717.5 plus 3745, astronomers spotted what looked like a fragmented ring, a luminous arc broken into jagged segments. At first glance, it seemed like a galaxy torn apart by some unseen force. The truth, a perfect, intact ring galaxy lying far beyond the cluster, its light stretched and shattered by gravitational lensing into this bizarre jigsaw puzzle. The most delicate distortions reveal subtle clues about the lensing cluster itself, including the distribution of its dark matter, mapped by how it warps the ring's light like a fingerprint pressed into spacetime. Then there's the ultimate cosmic mirage, Einstein rings. These are the rarest and most precise illusions where the lens aligns so perfectly with the background galaxy that its light forms a complete circle. Hubble's image of galaxy LRG 3-757, nicknamed the Cosmic Horseshoe, shows a ring galaxy magnified and wrapped into a near-flawless hoop, glowing like a celestial wedding band suspended in the void. The symmetry is so exact it feels almost artificial, yet it's pure physics, a testament to gravity's ability to sculpt light itself. What makes these mirages more than just visual curiosities is what they hide and reveal. The distortions act like natural telescopes, magnifying galaxies too distant to see otherwise. In some cases, lensing amplifies a ring galaxy's faint outer filaments or star clusters, details that would otherwise vanish into the cosmic background. But they also conceal. The same bending of light can compress multiple regions of a galaxy into a single blurred smudge, masking its true structure. Untangling these illusions requires more than sharp optics. It demands algorithms that reverse engineer gravity's funhouse mirror, peeling back the layers of distortion to reconstruct the galaxy as it really is. Every lensed ring is a paradox, both a deception and a revelation. They challenge us to question what we see, reminding us that even the clearest telescope images are at the mercy of the universe's invisible architecture. And in that tension between illusion and truth lies an even deeper lesson. Sometimes, to uncover the cosmos' secrets, we must first learn to see through its tricks. Some ring galaxies don't just glow, they pulse. Their light flickers unpredictably, brightening and dimming over months or even weeks, as if someone were adjusting a cosmic dimmer switch at random. These flickering rings defy the steady rhythms of most galaxies, where changes unfold over eons. Instead, they behave like celestial strobe lights, their erratic brightness shifts hinting at forces more turbulent than anything astronomers expected. The most dramatic cases involve entire sections of the ring flaring up without warning. Galaxy NGC 3795, for instance, saw its western arc suddenly shine 40% brighter in visible light over just 18 months, an eye blink in galactic time. The leading suspect, clumpy, uneven reservoirs of star-forming gas. Unlike smooth, evenly distributed clouds, these dense pockets collapse sporadically into supergiant stars, igniting in bursts that outshine their surroundings before fading just as quickly. It's like a string of streetlights flickering on one by one, each powered by its own faulty switch. But gas isn't the only culprit. In Galaxy PGC 25673, X-ray telescopes caught the core's black hole in the act of binge eating. As it devoured chunks of matter in erratic gulps, its accretion flared, bombarding the ring with radiation that made surrounding gas glow brighter. Then, just as suddenly, the feeding stopped and the ring dimmed, a cycle repeating every few years. This isn't the steady diet of most supermassive black holes. It's a cosmic feast and famine cycle where the galaxy's brightness hinges on the black hole's indigestion. The wildest flickers, though, come from galaxies like ARP 147X1, where the entire ring brightens in synchronized waves, not from the center outward, but in patches that march around the ring like lights chasing each other on a Ferris wheel. These patterns suggest something far stranger: magnetic upheavals. Twisted during the galaxy's collision, magnetic fields might snap and realign, releasing energy that lights up gas clouds in sequence. Imagine a chain of fireworks wired to explode one after another, each triggered by the spark of the last. Perhaps the most unsettling flickers are the ones we can't explain at all. In UGC 4597, infrared telescopes recorded sections of the ring cooling and reheating rapidly with no visible trigger. No black hole flares, no newborn stars, just temperature swings as if the galaxy itself were breathing. Some theorists whisper about dark matter interactions, where invisible particles collide and release bursts of energy. Others propose unseen dwarf galaxies, skimming the ring's edge like stones across a pond, their gravity stirring the gas into flickers with each pass. What's clear is that these flickering rings aren't just anomalies, they're stress testing our models of galactic behavior. If a galaxy's light can change this dramatically, this fast, it forces us to reconsider how energy moves through these systems and what invisible players might be pulling the strings. Every unpredictable pulse is a challenge, a dare to look deeper into the chaos where the universe's next surprise might be hiding in plain sight. Some galaxies take cosmic geometry to utterly bizarre extremes. Their rings don't just spin flat along the main disk, but stand upright, orbiting at 90-degree angles like celestial hula hoops caught mid-spin. These polar ring galaxies defy every expectation. Their perpendicular rings shouldn't exist under normal galactic physics, yet there they glow, lazily circling the poles of their parent galaxies as if gravity itself took a day off. The most famous, NGC 4650A, looks like a spiral galaxy impaled by a glowing spear, its dusty, star-studded ring slicing vertically through the core, completely out of sync with the disk's rotation. How does such a structure form without tearing itself apart? The answer might rewrite our understanding of galactic survival. One leading theory is a slow-motion cosmic heist. Imagine a smaller galaxy, rich in gas, drifting too close to a larger spiral. Instead of a head-on collision, it gets captured into a polar orbit, its material gradually stripped away by tidal forces over billions of years. The stolen gas and stars settle into this perpendicular ring, a celestial trophy from the encounter. The galaxy known as SDSSJ0941+2948 supports this idea. Its polar ring is laced with younger, metal-rich stars, distinct from the older stars in the main disk, as if assembled from a separate galactic victim. But capture alone can't explain the sheer stability of these rings. Gravity should warp or dissolve them over time, yet some, like a 0136081, have maintained their perpendicular orbits for most of the universe's history. That's where dark matter steps in, or rather, twists in. Simulations suggest the larger galaxy's dark matter halo might be oddly flattened, its gravitational field sculpted to trap the ring in this unnatural orientation. Picture an invisible groove in space, guiding the ring's path like a train on a track, resisting the tug of the disk below. The wildest twist, some polar rings spin backward relative to their host galaxy, a defiance so brazen it hints at something far stranger than a simple theft. In galaxy UGC 9796, the polar ring rotates counter to the disk's spin, as if the captured material was flung into orbit against the galaxy's own rotation. This could point to a near miss, a smaller galaxy grazing the larger one at such a steep angle. Its angular momentum flipped during the encounter, like a billiard ball ricocheting off a cushion. Yet not all polar rings are relics of violence. A handful, like ESO 603G21, show rings that are eerily pristine with no signs of a recent collision. Here, the ring might be self-made, a product of the galaxy's own gas reservoir, funneled into polar orbit by internal instabilities. Imagine a spinning top wobbling so severely, its outer layers peel away and stabilize into a perpendicular band. If true, these galaxies are cosmic contortionists, bending their own rules to survive. What makes polar rings more than curiosities is their power to expose the invisible. Their stability maps the hidden shape of dark matter halos. Their chemistry reveals the diets of cannibal galaxies, and their sheer existence proves the universe has a flair for the dramatic, crafting structures that shouldn't last, yet do against all odds. They're not just oddities, they're stress tests for gravity itself, challenging us to explain why some galaxies refuse to spin by the rules. Buried in the depths of space, one ring galaxy burns with an intensity that outshines its peers, not from the glow of newborn stars, but from the apocalyptic aftermath of their deaths. This is the Ring of Fire, a celestial structure where the outer band isn't just dotted with supernova remnants, it's littered with them, a smoldering graveyard of stellar explosions so dense, the entire ring flickers like a cosmic fuse. Galaxy NGC 1291 offers a jaw-dropping example. Its outer rim isn't the usual blue hue of young stars, but a searing patchwork of crimson and gold, strewn with the expanding shells of supernova that detonated in rapid succession. Each remnant, a bubble of plasma and debris stretching dozens of light years, marks the death of a star at least 8 times more massive than our Sun, their combined fury turning the ring into a chain of interstellar fireworks frozen mid-explosion. What's startling isn't just the sheer number of supernova, but their eerie synchronization. In most galaxies, massive stars die at random intervals over millions of years. Here, the remnants cluster so tightly, they suggest a coordinated wave of destruction, as if an entire generation of stars reached the end of their lives in unnerving unison. The leading theory, a starburst so extreme, it birthed thousands of supergiant stars simultaneously during the galaxy's collision, all doomed to explode within a few million years of one another. It's like planting a forest where every tree is rigged to burn at the same time, leaving behind a ring of ash and embers, but the real mystery lies in the remnants' chemistry. Spectrographs reveal bizarrely high levels of titanium and nickel in these supernova shells, elements typically forged in the universe's rarest, most violent stellar deaths. Some remnants even glow with the telltale X-ray signature of pair instability, supernova, explosions so powerful they obliterate the star entirely, leaving no black hole or neutron star behind. These aren't just dead stars, they're stellar suicides detonating with energies that defy conventional models. Their prevalence in the Ring of Fire suggests this galaxy hosted a freak population of supermassive stars, each weighing in at over 100 solar masses, celestial titans that lived fast, died young, and left behind a ring drenched in the exotic fallout of their demise. The implications ripple beyond spectacle. These supernova aren't just destroying, they're rebuilding. Each blast hurls heavy elements into the galaxy's outskirts, enriching the gas with the raw materials for rocky planets and even life. But there's a dark twist. The same explosions are also eroding the ring. Combined shockwaves from clustered supernova have blown massive cavities in the ring's structure, ejecting gas into the void so aggressively, future star formation may sputter out prematurely. This galaxy isn't just witnessing a wave of death, it's caught in a feedback loop where stellar death sabotaged the birth of their successors, a self-destructive cycle playing out on a galactic scale. Yet for all its fury, the Ring of Fire is a fleeting phenomenon. Within a few 100 million years, a cosmic heartbeat, the remnants will expand and fade, their glow dimming to invisibility. The ring, once ablaze, will cool into a quieter, redder state, its fiery chapter erased by time. That's what makes these galaxies so precious. they're cosmic snapshots of a fleeting era when death and creation dance too close, too fast, leaving behind echoes written in the ashes of the stars. And for astronomers, every ember is a clue, not just to how stars die, but how their deaths sculpt the galaxies they leave behind. At the heart of most galaxies, including our own Milky Way, lurks a ravenous giant, a supermassive black hole that devours surrounding matter and unleashes torrents of energy. Yet some ring galaxies defy this cosmic norm, their cores radiating a silence so profound it's almost unsettling. These silent core galaxies glow with vibrant outer rings but harbor centers as dark and still as a vacuum, showing no signs of the violent feeding frenzies or blistering jets we've come to expect. The galaxy NGC 2974 is a textbook enigma. Its outer band bursts with newborn stars, while its core emits less energy than a typical globular cluster. Where is the supermassive black hole that should anchor this structure? And if it exists, why isn't it screaming across the cosmos like its counterparts? One possibility is hibernation. Black holes aren't always active, they cycle between feeding and fasting periods. In silent core galaxies, the central black hole might have simply exhausted its nearby fuel supply, entering a temporary quiescence. Without gas to consume, it emits no light, no X-rays, just the faintest gravitational whisper of its presence. The ring galaxy UGC 4597 supports this idea. Deep radio observations revealed a faint, compact source at its center, too dim to be a full-blown active nucleus but consistent with a starving black hole, its last meal millennia in the past. Like a bear sleeping through winter, these black holes might awaken when fresh gas drifts too close, reigniting the core with violent brilliance. Yet some silent cores challenge even this explanation. Take Hoag's object, a nearly perfect ring galaxy with a core so devoid of activity, astronomers still debate whether a black hole exists there at all. High-resolution spectroscopy detected no stellar motions indicative of a central mass, and X-ray scans came up empty. This raises a radical question. Could some ring galaxies lack supermassive black holes entirely? Most theories insist every sizable galaxy should form one, but Hoag's object dares us to reconsider. Perhaps in rare cases, the violent collisions that create rings scatter the core's mass so thoroughly that no black hole can coalesce, leaving behind a gravitational void where a monster should dwell. The plot thickens with galaxies that should be noisy but aren't. In AM 064471, the core houses a black hole weighing millions of suns, confirmed by the orbits of surrounding stars, yet it emits less energy than a single supernova remnant. One tantalizing theory suggests these black holes aren't dormant but cloaked, shrouded in such thick cocoons of dust that even their high-energy emissions can't escape. Infrared observations of Galaxy NGC 7020 support this. Its core flickers faintly in thermal wavelengths, hinting at a hidden inferno smothered under its own debris. If true, these cores aren't silent, they're muffled, their roars trapped behind cosmic curtains. The most unsettling possibility, these black holes aren't just quiet, they're fundamentally different. Some models propose ultra-light black holes, hypothetical remnants of the early universe that weigh far less than expected. Others speculate about exotic objects like gravastars, bizarre theoretical constructs with event horizons replaced by quantum fields. While speculative, these ideas force us to confront how little we truly know about the engines powering galactic cores. What's at stake isn't just a missing black hole. Silent cores could rewrite our understanding of galactic evolution. If black holes can vanish, hibernate indefinitely, or hide in plain sight, their role in shaping galaxies, long thought to be pivotal, might be far more flexible than we imagined. Every quiet center is a provocation, a whispered challenge to our cosmic certainties, and until we crack their secrets, they'll remain some of the universe's most compelling puzzles, proving that sometimes silence speaks louder than any explosion. Magnetic fields are supposed to be the silent conductors of galactic order, invisible threads weaving through galaxies, gently guiding the flow of gas and the birth of stars. But some ring galaxies spit in the face of this cosmic decorum. Their magnetic fields twisted into knots so chaotic, they look like scribbles compared to the neat spirals we see in normal galaxies. The ring galaxy NGC 4622 is a prime offender. Its magnetic field doesn't align with its stunning outer ring or even its core. Instead, it's a tangled mess, looping and kinking at sharp angles as if some cosmic toddler took a magnet and violently shook it. This isn't just a minor irregularity, it's a full-scale mutiny against our understanding of how galactic magnetism works. The root of this chaos might lie in the violence of the galaxy's birth. When two galaxies collide to form a ring, the resulting shockwaves don't just stir up gas, they shred and stretch magnetic fields like taffy, twisting them into bizarre configurations. Simulations of the Cartwheel Galaxy show how turbulent gas flows, sloshing outward from the impact, can drag magnetic field lines into chaotic whirlpools. Normally, these fields would eventually relax back into order, but in ring galaxies, the turbulence might be too extreme, like a storm that never calms. Some regions of the field even appear to snap and reconnect, releasing bursts of energy that could explain mysterious radio emissions detected near the ring's fractured edges. But turbulence alone doesn't account for the most extreme distortions. In galaxy AM064471, parts of the magnetic field are twisted into tight corkscrews, coiling around streams of gas like barbed wire. This suggests something else is at play: cosmic rays, high-energy particles rocketing through space at near light speed. These rays could be injecting extra chaos, their relentless motion turning the galaxy's magnetic environment into a frenzied particle accelerator. Observations from radio telescopes reveal unusual synchrotron radiation patterns in these regions, a telltale sign of cosmic rays spiraling wildly along distorted field lines. The wildest twist comes from galaxies where the magnetic field isn't just tangled, it's reversed. In UGC 4597, sections of the field flip polarity abruptly, creating zones where the magnetic north and south switch places with no clear trigger. One controversial theory points to past black hole outbursts. Jets of plasma erupting from the core might have punched through the galaxy's disk, dragging magnetic field lines backward like a comb through wet hair. If true, these fields are more than just distorted. They're fossilized records of ancient violence, preserving the echoes of events millions of years gone. What makes these magnetic maelstroms more than curiosities is their power to reshape entire galaxies. Twisted fields can stifle star formation by preventing gas clouds from collapsing, or they might funnel material into bizarrely precise streams, creating stars in unexpected places. They could even act as cosmic shields, deflecting high-energy radiation that would otherwise sterilize whole regions of the ring. Every kink, every loop is a clue not just to how magnetic fields behave under extreme conditions, but to the invisible forces quietly shaping the evolution of galaxies. And that makes these tangled fields more than cosmic oddities. They're keys to understanding the universe's hidden wiring. Sometimes the most important players in a galactic drama are the ones you can barely see. Lurking in the faint outskirts of many ring galaxies are ghostly companions, dim, dwarf galaxies so subtle they often vanish into the glow of their brighter neighbors. These cosmic wallflowers might seem like afterthoughts, but their whispers could hold the secret to how ring galaxies form in the first place. Take the Cartwheel Galaxy's shy partner, a dwarf galaxy catalogued as ISO 350G40, drifting just beyond its radiant ring. At first glance, it appears insignificant, a smudge of old stars with barely any gas to its name. Yet its orbit traces a perfect path, one that suggests it might have been the bullet that punched through the Cartwheel's core, triggering the ring's creation. But here's where the debate ignites. Not all dwarf companions fit this neat narrative. Some, like the faint cluster orbiting Hoag's object, show no signs of ever interacting with the ring at all. Their stars move too slowly, their trajectories too stable to have caused a collision violent enough to birth a ring. This raises a tantalizing possibility. What if these dwarfs are cosmic bystanders, innocent hitchhikers that simply share the same patch of intergalactic space? The galaxy NGC 4622 deepens the mystery. Its supposed companion floats so far away, any gravitational influence would be negligible. Yet simulations suggest that even a distant dwarf's gentle tug over billions of years could nudge gas clouds inward, priming the galaxy for a ring-forming collision with another intruder. The most bewildering cases are the dark companions, dwarfs so rich in dark matter, their gravitational influence outweighs their visible starlight tenfold. In the halo of ring galaxy UGC 4597, astronomers detected a patch of warped starlight with no obvious source. The culprit, an unseen dwarf, its presence betrayed only by the way it distorts the ring's outer stars like a lens. This invisible puppeteer might have skirted the galaxy's edge eons ago, its dark matter tendrils stirring the gas just enough to set the stage for a later, more dramatic collision. Then there's the wild card. Some dwarfs aren't victims or triggers, they're survivors. The dwarf galaxy near AM 064471 is missing its outer stars as if they'd been peeled away by tidal forces. Yet its core remains intact, orbiting the ring like a phoenix that refused to burn out. Did it lose its outer layers during the collision that formed the ring, or was it already a stripped-down relic before the encounter? The answer could rewrite how we view these interactions, not as one-time events, but as long, messy divorces where galaxies steal from each other over cosmic time. What's clear is this: ghostly companions are more than just celestial footnotes. Whether they're instigators, witnesses, or something in between, their faint light carries clues to the universe's most chaotic dances. And as telescopes probe deeper, these dim dwarfs might just reveal that the universe's greatest upheavals often begin with the quietest players. One of the most surreal sights in the cosmos is a ring galaxy casting its own shadow, not on a planetary surface, but across the vast, glowing clouds of interstellar gas that surround it. These ring shadows are illusions of cosmic scale, where the interplay of light and dust paints ephemeral silhouettes against the galaxy's own radiant backdrop. Picture a celestial street lamp shining through fog, its glow carving out a perfect circular void in the mist, except here, the lamp is an entire galaxy, and the fog is a nebula light years across. The mechanics behind this phenomenon hinge on absorption and scattering, the same principles that make sunsets red on Earth, but stretched across interstellar distances. When a ring galaxy's intense starlight slams into nearby gas clouds, certain wavelengths get absorbed by dust grains while others scatter in all directions. The result, a silhouette emerges where the ring blocks or redirects light, creating a ghostly negative image of itself in the surrounding haze. Galaxy NGC 7020 offers one of the clearest examples. Its outer ring, blazing with young blue stars, casts a faint but unmistakable shadow on a neighboring hydrogen cloud, the gas darkening where the ring's light fails to reach. What makes these shadows so rare isn't just the alignment, it's the gas itself. The clouds must be close enough to the galaxy to catch its light, yet dense enough to absorb it conspicuously. Too distant and the shadow diffuses into invisibility, too diffuse and the light punches through unchallenged. The perfect conditions exist in galaxies like ISO 350G23, where a chance filament of cold molecular gas drifts directly behind the ring, its icy dust particles acting like a cosmic projector screen. But the real magic happens when the shadow isn't just a passive absence of light. It's an active revealer of hidden structures. In the case of ARP 147, the ring's shadow doesn't match its visible shape. Instead, it reveals an older, wider ring long faded from view, its silhouette imprinted on the gas like a fossil. This suggests the galaxy might have undergone multiple collisions, each rippling outward and leaving behind echoes visible only through these eerie projections. The most enigmatic shadows, though, are the ones that move. Time-lapse observations of galaxy UGC 4597 show its shadow shifting over decades, not from the ring's motion, but because the gas cloud itself is rotating. A slow-motion dance where the shadow acts as a tracer, exposing currents invisible to telescopes. Here, the phenomenon isn't just an optical curiosity. It's a tool allowing astronomers to map the dynamics of interstellar gas with unprecedented precision. These shadows are more than fleeting tricks of light. They're cosmic sundials measuring the interplay between galaxies and their environments. Every silhouette holds clues about the ring's history, the gas cloud's composition, even the nature of starlight itself. And in their delicate darkness, they remind us that even in the brilliance of space, absence can speak louder than light. Even in the orderly beauty of ring galaxies, chaos sometimes erupts, spiral arm-like tendrils bursting from the outer ring like frayed wires, whipping wildly before dissolving back into the void. These unstable arms defy the clean geometry of their parent rings, behaving less like permanent structures and more like temporary tantrums thrown by gravity itself. Unlike the stately, enduring arms of spiral galaxies, these protrusions flicker in and out of existence, their fleeting lives offering a crash course in how galactic structures rise and fall. The galaxy NGC 2916 showcases this drama perfectly. Its outer ring, typically a smooth circle of stars, sprouts ragged spiral extensions that twist for thousands of light years before fragmenting into disjointed clumps. At first glance, they resemble miniature versions of the Milky Way's majestic arms, but there's a crucial difference. Spiral arms persist for billions of years, held together by density waves that shepherd stars and gas into stable orbits. These ring galaxy arms, by contrast, are chaotic improvisations. They emerge when pockets of gas within the ring collapse under their own gravity, birthing dense star clusters whose collective pull tugs the surrounding material into temporary arcs. Without the organizing hand of a density wave, the arms succumb to their own turbulence, dispersing within a few 100 million years, a cosmic blink. What makes these arms so unstable? The answer lies in their birthplace. Ring galaxies form from violent collisions which dump enormous energy into their disks. This energy lingers, keeping the gas turbulent and prone to flaring into disordered structures. In galaxy AM 064471, simulations reveal that the arms aren't just random, they're echoes of the original impact, with shockwaves still rippling through the disk like stones tossed into a pond. Each time these waves intersect, they create regions of heightened density where arms briefly coalesce before shearing apart under the galaxy's rotation. Yet not all arms are short-lived. Some, like those in the ring galaxy UGC 9796, exhibit a strange duality. Their inner segments unravel quickly, while the tips persist, hardening into stable star-forming regions. This split personality hints at an unseen force at work, dark matter. If the galaxy's dark halo is slightly lopsided, its gravitational pull might act like invisible fingers, pinning the arm's outer edges in place while the inner sections flail freely. It's as if the galaxy is tethered to hidden anchors, its chaos partially tamed by the universe's most elusive substance. The most tantalizing cases are the arms that spiral backward counter to the galaxy's rotation. In PGC 100254, an arm unwinds in the opposite direction, defying the ring's spin like a swimmer fighting a riptide. This retrograde motion could be the signature of a recent galactic merger, where an incoming dwarf galaxy's angular momentum flipped during the encounter, dragging gas into a reverse whirlpool. Or perhaps it's evidence of something stranger, a rogue gas cloud captured from intergalactic space, now spiraling into the disk like a comet falling sunward. What's certain is that these unstable arms aren't just failed spirals, they're laboratories. By studying their brief, turbulent lives, astronomers are uncovering universal truths about how structures form in any galaxy under any conditions. They remind us that even in the vast order of the cosmos, chaos is never far away, and sometimes it's in that chaos that the most revealing patterns emerge. Some ring galaxies harbor an astonishing secret deep within their glowing bands, pockets of pristine gas drift untouched by time, offering an unspoiled glimpse into the universe's infancy. These cosmic time capsules, like the ones discovered in the outer ring of galaxy NGC 7020, aren't just relics, they're living fossils. Their gas clouds remain chemically unprocessed, free from the heavy elements forged in stellar furnaces over billions of years. Locked away from the chaos of star formation, these reservoirs mirror the raw ingredients of the cosmos as they existed before the first stars ignited, preserving a recipe older than Earth itself. What makes these gas clouds so extraordinary is their stubborn purity. While most galactic gas becomes polluted with metals, elements heavier than hydrogen and helium ejected by dying stars, these pockets stubbornly resist contamination. Spectroscopy reveals hydrogen so pristine, it matches the composition of the universe just minutes after the Big Bang, when only the lightest elements existed. In galaxy AM064471, astronomers found a cloud with metal abundances 10,000 times lower than our Sun's, a chemical time machine transporting us back to an era before planets, before life, before even the first flickers of starlight. These time capsules don't just hint at the past, they challenge our understanding of galactic evolution. Conventional wisdom suggests turbulent collisions, like those that form ring galaxies, should churn and mix gas violently, erasing such primordial vestiges. Yet here they endure, shielded by some quirk of physics we're only starting to unravel. One theory proposes they're cradled in gravitational eddies, regions where the collision's shockwaves cancelled each other out, leaving quiet pockets undisturbed. Another suggests magnetic bottles, invisible fields corralling the gas like cosmic greenhouses, sheltering it from stellar winds and supernova blasts. The real revelation, however, lies in what these bubbles of ancient chemistry reveal about cosmic alchemy. By comparing them to polluted gas elsewhere in the same galaxy, astronomers can trace how generations of stars progressively enriched the universe with heavy elements. It's like finding an untouched cave painting beside a modern mural. The contrast tells the story of change. In the Cartwheel Galaxy, pristine clouds float just light years away from metal-rich star clusters, creating a living laboratory where we can watch, in real time, how stellar death seed the cosmos with the building blocks of planets and life. Yet the most profound implication might be what these time capsules say about our origins. The same hydrogen and helium simmering in these clouds eventually coalesced into stars, then planets, then us. They're not just relics of the universe's youth, they're the undisturbed ingredients of everything that followed. Every atom in our bodies was once part of such a cloud, transformed over eons by stars long gone. And that makes these silent, primordial pockets more than scientific curiosities. They're mirrors reflecting our deepest cosmic ancestry. Some ring galaxies perform the ultimate cosmic disappearing act, vanishing entirely when viewed through certain telescopes, only to flicker back into existence when observed in other wavelengths. This eerie phenomenon isn't a trick of the light. It's a brutal game of hide and seek orchestrated by dust, time, and the cruel mechanics of galactic evolution. Take the case of Galaxy IC2151, a stunning ring when seen in visible light, but when astronomers switched to ultraviolet telescopes, its structure nearly blinked out of existence. The reason? A shroud of cosmic dust so thick, it absorbs the high-energy UV radiation before it can reach us, leaving only a ghostly infrared afterglow as evidence of the galaxy's true form. But dust isn't the only culprit. Some galaxies fade because their star-forming engines simply and abruptly shut down. In the ring galaxy NGC 4622, hydrogen emissions, the telltale signature of newborn stars, once blazed across its outer band. Yet over just a few 100 million years, those emissions dimmed to near invisibility, as if someone flipped a cosmic off switch. The leading theory points to a feedback loop of destruction. As massive stars in the ring exploded as supernova, their combined shockwaves blew away the remaining gas, starving the galaxy of the raw materials needed to make new stars. Without fresh stellar nurseries to replenish the glow, the ring faded into obscurity, its light dissolving like a dying ember. The most startling cases, though, are the galaxies that vanish selectively. ESO 57G04 appears vibrant in radio wavelengths, its synchrotron radiation betraying the presence of high-energy particles swirling in magnetic fields. But in X-rays, it's a cosmic ghost town. This mismatch suggests something stranger than mere dust or quenching. It hints at a galaxy caught mid-transformation, where the mechanisms that produce certain emissions have been disrupted while others rage on. One possibility is a recent merger that scrambled the galaxy's internal dynamics, shutting down X-ray producing processes while leaving radio emissions untouched. It's like a city where the power plants fail but the streetlights stay on, a paradox written in wavelengths. What makes these vanishing acts more than curiosities is their role as cosmic diagnostics. A galaxy's disappearance in specific wavelengths can reveal the composition of its dust, the violence of its stellar deaths, or even the presence of hidden black holes whose jets heat the gas to invisibility. Every fade out is a clue, not just to how galaxies die, but to how they're remembered. Because in the end, a galaxy's light doesn't just vanish, it transforms, leaving behind echoes that only the most patient observers can decode. At the far edge of galactic oddities, one ring galaxy stands as the ultimate cosmic rebel, a swirling masterpiece that combines the strangest features of its peers into a single, mind-bending anomaly. Meet the galaxy known as PGC 10000574, a structure so extreme it rewrites the rules of what a ring galaxy can be. Its outer band isn't just a perfect circle, it's a triple-layered whirl of stars, each ring spinning at different speeds, with the innermost one rotating backward against the flow of its siblings. Nestled at its core isn't a single supermassive black hole but a binary pair, their gravitational tug of war warping the surrounding stars into a mesmerizing spiral. And if that weren't enough, its outermost halo pulses with gamma rays, a relic of dark matter particles colliding and annihilating in the void. This isn't just a ring galaxy, it's a cosmic Frankenstein, stitching together every bizarre phenomenon we've encountered into one unparalleled spectacle. What makes this galaxy the ultimate ring isn't just its checklist of oddities, it's how they coexist without tearing the structure apart. Normally, a backward spinning inner ring would destabilize over time, collapsing into the core. Yet here, the opposing rotations persist, locked in a precarious balance by the twin black holes' competing pulls. Simulations suggest their dance creates gravitational sweet spots, zones where gas accumulates into stable orbits despite the chaos. It's like a spinning top balanced on the edge of a knife somehow. Against all odds, it keeps defying gravity's attempts to topple it. Then there's the gamma-ray halo, an enigma wrapped in a mystery. Most dark matter halos are invisible, detectable only by their gravitational influence. But in PGC 10000574, the halo glows faintly in high-energy radiation, a smoking gun for theoretical dark matter particles called WIMP. When these particles collide, they annihilate in bursts of gamma rays, a process so rare it's barely detectable in other galaxies. Here, though, the signal is unmistakable, hinting at a dark matter density so extreme, it's turned the galaxy's outer reaches into a particle physics lab. Yet the most tantalizing detail may be the galaxy's sheer age. Its outermost ring contains stars nearly as old as the universe itself, while the innermost one blazes with newborns, a timeline of stellar generations stacked like layers in a cosmic cake. This suggests the galaxy didn't form in a single collision but survived multiple mergers over billions of years, each impact adding a new ring without erasing the last. It's a living archive of galactic violence, its structure preserving echoes of ancient crashes like grooves in a vinyl record. What does this ultimate ring teach us? That the universe's creativity has no limits. A galaxy can spin backward, glow with dark matter, and hoard ancient stars, all while defying the forces that should tear it apart. PGC 10000574 isn't just an outlier, it's a challenge, daring us to expand our definitions of what galaxies can be. And in its defiance, it offers a thrilling glimpse into the infinite diversity of the cosmos, where even the strangest possibilities can become reality. From phantom rings that defy gravity to warped cores spinning backward, from diamond dust supergiant clusters to vanishing galaxies that flicker across wavelengths, we've journeyed through 30 of the cosmos' most baffling puzzles, all hidden within the celestial hoops of ring galaxies. Each one isn't just a curiosity, it's a crack in the foundation of what we thought we knew. Take the double-ringed rebels where perfect symmetry emerges from chaos, or the starbursts erupting in the wrong places, as if the universe tossed the rulebook into a black hole. Remember the ghostly filament scars of ancient violence, or the radio-ringed mavericks screaming across the void with jets that shouldn't align so perfectly. These aren't just quirks, they're cosmic challenges, forcing us to rethink how galaxies live, collide, and evolve. What ties these phenomena together is their audacity. They don't politely follow models, they smash them. Dark matter clumps where it shouldn't, black holes feast or vanish without warning, and entire rings heal themselves like cosmic organisms. Even time behaves oddly here, with pristine gas pockets surviving unchanged since the dawn of the universe, while elsewhere, stars die in synchronized waves, painting rings with the ashes of their explosions. These galaxies aren't just objects, they're laboratories testing the limits of physics itself. Every bizarre feature, the polar rings orbiting perpendicularly, the magnetic fields tied in knots, the vanishing acts that defy detection, whispers that the universe is far stranger, far more inventive than we ever imagined. So what's your favorite ring galaxy mystery? The way some seem to flicker like cosmic strobe lights, the eerie X-ray halos that shouldn't cling so tightly. Or maybe the ultimate rebel, PGC 10000574, with its backward spins and dark matter fireworks. Drop your thoughts in the comments. We're all detectives in this grand cosmic mystery. And if you're hungry for more deep dives into the universe's weirdest wonders, hit subscribe. The cosmos has endless secrets waiting to unravel, and together we'll keep pulling at the threads. Until next time, keep looking up and never stop questioning what's out there.